here's what a reference angle is. So if you look at this 150 degrees, my reference angle is that angle that gets me to the x-axis. Always to the x-axis. So in this case, if I have 150 degrees, that additional 30 degrees is my reference angle. That 30 degrees is my reference angle. It gets me to my x-axis. In other words, it gets me to 180 degrees. It gets me to 180 degrees. So that's if I'm in quadrant 2. I'm going to riff on this graph a little bit. Piggyback, so you don't have to, it might be okay to write this down. But let's say I'm in quadrant 3. Let's say I'm an angle in quadrant 3. Let's say I am, 220 degrees. My reference angle is that angle that gets me back to the x-axis. In other words, it gets me back to 180 degrees. It has to be positive. A reference angle is always going to be positive, and it's always going to be between 0 and 90 degrees. Does anyone take a shot at what the reference angle is there? What is that reference angle?
40 degrees.
Thank you, Liam, for raising your hand. Liam, what is it? What was that?
45 degrees. 40 degrees.
It is 40 degrees. It is 40 degrees. It's 40 degrees because 220 minus 40 degrees gets me my 80.
Right.
Yep. All right, one last one we'll do together is, let's say I'm in quadrant 4. All right, I'm in quadrant 4. What would be a good quadrant 4 angle? I don't know, 315
Wow.
degrees.
I know the answer.
You gave me the angle, you better know the, yeah, what's the reference angle?
45 degrees.
It would be 45 degrees because 45 degrees gets me to 360. So realistically, I'm looking at how do I get to 180? And if I'm in the 4th quadrant, how do I get to 360 degrees? If I'm in quadrant 1, if the angle is in quadrant 1, it is already its own reference angle. So when I say what's the reference angle of 45 degrees, you're going to say
45
it's 45 degrees. Yeah, perfect. That leads us to this. If you are in quadrant 1, you yourself are your own reference angle. If you are in quadrant 2, all you're going to do is you're going to do 180 minus that given angle. If you're in quadrant 3, you're going to do your angle minus 180. And finally, if you're in quadrant 4, you're going to do 360 minus your angle. We're going to talk about, too, why the order of it isn't all that important. Just knowing it needs to be between 0 and 90 is the most important part. Okay. For this lesson, we're going to forget about the entire unit circle, and we're just going to know quadrant 1. That's all we're going to know. We can't use any other quadrant. We also have to have a quick refresher on whether something's positive or negative in a given quadrant. Because if I'm in quadrant 3, I got to know whether it should be positive or negative. Well, the first column's pretty easy. If I'm in quadrant 1, I'm positive no matter whether I'm sine, cosine, or tangent, which means their reciprocals are also positive. Quadrant 2, we just have to do that all students take calculus thing. So all students, quadrant 2, sine is positive, which means all the other ones are negative. Quadrant 3, all students take, that's going to be tangent is positive. Everything else is negative. And finally, quadrant 4, all students take calculus. That is C for cosine. Cosine's positive. Everything else is negative. So the only bits of information we really need to know for reference angles are quadrant 1 and whether it should be positive or negative. So I'm going to go through my whole thought process. I don't expect you to do this on your homework, writing all of this stuff down. But this is kind of what's happening in my head. So 210 degrees. I'm picturing 210 degrees on the unit circle. Well, 210 degrees is going to be in quadrant 3 because it's bigger than 180 and it's smaller than 270. So this is about 210 degrees. So even without doing any math, I'm going to do all the math because degrees are pretty easy, radians get hard. So do all the math with me, and then the radians will be easier. What should my reference angle be? What should my reference angle be just from the picture? 30 degrees. And with degrees, you should be able to pretty much do all of it in your head. It's 30 degrees. I am not going to do it in my head because, like I said, when we get to radians, it's going to be more difficult. So what I'm thinking about in my head right now is, hey, I'm in quadrant 3. I'm looking for sine value, and sine is negative in quadrant 3. So my answer needs to be negative. Then I'm going to say, well, in quadrant 3, we are going to do 210 minus 180 to get my reference angle. Well, my reference angle for this one is 30 degrees. We already knew that, but we're kind of prepping ourselves for when we get to radians. So that reference angle is 30 degrees. So rather than trying to figure out what sine of 210 degrees is, all I'm really trying to think about is what is the negative sine of 30 degrees, which should be a lot easier because 210 degrees, now I have to figure out all these values all the way around, and I kind of have to picture what this looks like down here. Instead, I just need to know what sine of 30 degrees is. And what's the sine of 30 degrees? Try not to look at your quadrant 1. See if you can figure it out on your own. If you need to, you can look at the quadrant on the top. But it's going to be, Liam?
Never mind.
Okay. Charlie?
Is it a half?
It is a half. So it's going to be negative 1/2. Because we knew it had to be negative because it was in quadrant 3. And this way I didn't have to do anything besides quadrant 1 information. All right, cosine of negative 240. You can do reference angles with negatives, but it's just easier just to kind of come up with our coterminal angle right off the bat. So I'm going to do coterminal. My coterminal angle, our coterminal angle is an angle that's in the exact same place, but I want it to be positive, so I'm going to add 360 to it, which is going to give me 120. Remember, coterminal is different than reference angle. Coterminal is the exact same place on the unit circle. Reference is making it smaller, so it's between 0 and 90. So we're at 120, which means in my head I'm picturing a 120 degree angle. A 120 degree angle is going to be in quadrant 2. This is 120 degrees, so I am looking for this little angle here. Yes?
60 degrees.
It will be 60 degrees. Yep. Just by looking at it, it should be 60. That's why I was picturing it in my head. Let's check the math behind it. Quadrant 2. Cosine is supposed to be all students, so sine is positive, so that means cosine is negative. In quadrant 2, we are going to do, let's do it wrong.
No.
Why?
No.
I'm going to do it wrong. Don't write it down there.
No.
I'm just going to show you what happens if you do it wrong. I'm supposed to do 180 minus 120.
That's wrong.
That is correct.
All right, never mind. That's right.
I am supposed to do 180 minus 120 to get my reference angle. Let's say I accidentally did 120 minus 180.
What a rookie mistake.
I have negative 60 degrees.
Oh.
If I'm smart and I realize it has to be between 0 and 90, it has to be positive, I'm just going to tell myself, well, I must have I subtracted it wrong. The actual answer should be a positive 60 degrees. You can do that. Just make it a positive 60 if you come out with a negative. Because if I did it the right way,
You bet your pants you did it wrong.
we would do 180 minus 120, which comes out to a positive 60 degrees. So as long as you know it should be positive, it doesn't matter which way if you accidentally flip the order. So our reference angle is 60 degrees. So rather than looking for the cosine of negative 240, all I have to do is know the cosine, the negative cosine of 60 degrees. And who knows the cosine of 60 degrees? Yeah, it is 1/2, so it's going to be a negative 1/2. Perfect. Our last one is tangent of 315. 315 must be in quadrant 4. That is my 315 degrees. My reference angle is going to be the guy that closes this gap here. which Mike picked this angle before, so it's going to be 45 degrees. Let's do the math behind it. Pretend like we're in radians and I can't figure this out. We are in quadrant 4. Tangent is negative in quadrant 4 because it's all students take. Tangent's only positive in first and third, so in fourth it is negative. In quadrant 4, I do 360 minus my angle of 315, which equals 45 degrees. And so I am actually looking for a negative tangent of 45 degrees, which is actually going to be a negative 1. Now, before we get to the next thing, the other class of the question, how am I going to make sure that you use reference angles? Well, first of all, I'm going to say, what is the reference angle? I will specifically make you write the reference angle so you know how to find reference angles. I could also just put on there that part that you can't look at your full unit circle. You only can look at quadrant 1, so maybe I'll put a quadrant 1 on there or something. There's multiple ways I can make sure that you know how to do reference angles. So do not cheat this homework where you're just looking at your unit circle and filling it out really quick. Try to use reference angles as much as you can. All right, that being said, we are getting into the harder part, and that is radians. Yeah? You should. I think I settled on, I probably wouldn't even grade your unit circle. I'll just grade the values you get.
Okay.
So if you don't put the tangent values, but you know them, then you'll be fine. All right. Radians. The hardest part about radians is knowing what quadrant they're in, because we just don't use them that much. You can use your calculator if you wanted to, because remember it goes pi over 2, so you're looking for something that's 1/2. We're looking for something that's 1 over here. We're looking for something that's 3 over 2 down here. So you can use your calculator in decimals. Since we're using major ones have a very good clue of what quadrant they're in. In quadrant 1, these are all the key angles in quadrant 1. They are pi over 3, pi over 4, and pi over 6. So if you have a 1 in your numerator, and I mean like 1 pi, right? There's a 1 in front of the pi. If there's a 1 in front of your pi, you are in quadrant 1. All right, with these key angles. This does not work with every single radian measure out there. But for the key ones where I'm asking you to do reference angles on, yeah, this will work for all the ones I'm asking for reference angles on. So I know that's quadrant 1 because there's a 1 in front of it. Quadrant 2 values are going to have a nice pattern too, because we have 2 pi over 3, we have 3 pi over 4, and finally we have 5 pi over 6. The key part is that 2, 3, and 5. If you compare your numerator to your denominator, your numerator in quadrant 2 is going to be 1 less than your denominator. So your numerators are 1 less than your denominator. I just put they're 1 less. But they're 1 less than your denominator. The key is here in quadrant 3, they're actually going to be 1 more. You're going to have 4 pi over 3. You're going to have 5 pi over 4. And you're going to have 7 pi over 6. So your numerator is going to be 1 more. And that makes sense, because pi is our 180. So if you think of 5 divided by 6, that's pretty close to 1 pi, but it's definitely a little bit less. 7 divided by 6 is a little bit more than 1 pi. All right, the final one is quadrant 4. This is kind of the oddball one. We have 5 pi over 3. We're going to have 7 pi over 4. And finally, we're going to have 11 pi over 6. So like I look at it as kind of the oddball one. The other way you can look at it is if I add 1 more to each of these, it'll actually be 2 pi. So if I had 6 pi over 3, that would be 2 pi. If I had 8 pi over 4, that would be 2 pi. If I had 12 pi over 6, that would be 2 pi. So they're 1 away from being 2 pi in the numerator. The real key one is quadrant 2 and quadrant 3. Those are your ones that you probably will get. Kind of the hardest ones to picture. All right, so keeping that in mind, keeping what we just learned in mind, on my unit circle, where is 5 pi over 6? Is that quadrant 1, 2, 3, or 4? Or quadrant 6? Is it quadrant 7, 8? Yeah. It's going to be quadrant 2 because our numerator is 1 less than our denominator. So in my mind, I'm just kind of picturing it's out here. That is my 5 pi over 6. I'm looking for finishing this off. Well, in this case, I would normally do 180 minus my angle, but we're doing radians, so instead we're going to do pi minus it. But first, let's just talk, we're in quadrant 2, which means sine is actually positive here. And in quadrant 2, we do 180 minus, but in this case, we're going to do pi, because pi equals 180 degrees, minus 5 pi over 6, which is actually 6 pi over 6 minus 5 pi over 6, which actually just equals pi over 6. So rather than trying to figure out what sine 5 pi over 6 is, I can just figure out what is the positive version, which is already is, of sine of pi over 6. And what's the sine of pi over 6? Yeah, it is going to be 1/2. I think I overused the 1/2 angle here. All right, negative 8 pi over 3. I don't want to deal with negative, so I'm going to make it positive. I'm going to find a coterminal angle to start off with. Well, to find a coterminal angle of negative 8 pi over 3, I have to add 2 pi over and over and over again until it's positive. Well, adding 2 pi doesn't really help me because it doesn't have a common denominator, so I'm going to go right off the bat and go, well, I'm adding 6 pi over 3 because that is 2 pi. I'm just going to create that common denominator right off the bat. And I did that because I'm going to recognize, well, negative 8 plus 6 pi is still negative. So I'd actually have to add another 2 pi, which would be 6 pi over 3. Now we have negative 8 pi plus 6 pi is negative 2, plus 6 pi is going to be a positive 4 pi over 3. Now I know where it is on my unit circle. 4 pi over 3. 4 is 1 bigger than 3, so it's going to be in quadrant 3. So this is my 4 pi over 3. I'm looking for my reference angle. Since I am in quadrant 3, we're going to take our angle, 4 pi over 3, and we're going to subtract pi away from it. Once again, if I did it out of order, if I did pi minus 4 pi over 3, I would just come with the negative version, but it'd still be the correct angle. So we are going to have 4 pi over 3 minus 3 pi over 3, which is just pi over 3. All right, since we are in quadrant 3, my cosine should be negative. So I'm looking for a negative cosine of pi over 3, which is going to equal negative 1/2. Because the cosine of pi over 3 is 1/2. Has to be negative because I'm in quadrant 3. It's negative 1/2. Whew. All right, just one more. Just one more. We already did quadrant 1, 2. Now we have to do quadrant 3. 7 pi over 4 is in quadrant 3. So I'm talking about this angle here, which is 7 pi over 4. I am in quadrant 4. Did I say 3? Yeah. I feel like I said 3, but I meant 4. I'm in quadrant 4. Yes, it's in quadrant 4. Okay, it's quadrant 4 where tangent is actually negative because as all students take, tangent is positive in 3 and 1, so it's not in 4. So tangent is negative in quadrant 4. My reference angle, all we have to do is take 360 and subtract the angle. Well, 360 in radians is 2 pi. minus our 7 pi over 4 is going to be 8 pi over 4 minus 7 pi over 4, which is going to equal pi over 4. So I'm just looking for where is tangent, negative tangent pi over 4, which is going to be a negative 1. All right, any questions on those? Because we are in quadrant 4, and tangent is negative in quadrant 4.
Oh, okay.
Yep. Whatever sign is supposed to be in front, we have to put that at the end. Has to be. All right, so we have negative 1. All right, so tomorrow's quiz, the bulk of it is what we did yesterday. It's going to be a lot of, if I give you sine of pi over 2, you have to give me what value it is. Or if I give you sine inverse of the square root of 2 over 2, you have to give me what angle it is. All right, that's going to be the bulk of tomorrow's quiz. There could be some graphing on there. And for reference angles, I'll probably just say, what's the reference angle for this given angle? I might say, what's the reference angle of 7 pi over 4? So you have to know how to find your reference angles. But that is the bulk of the quiz. You will have the entire class to work on the quiz tomorrow, but time might not be, you can't really figure stuff out in this. It's either you kind of know the unit circle and how to read it, or you don't. But you'll have the whole class. You may need it, you may not. All right? Any questions? Okay, any questions from the homework? I can tell you right now, after writing the quiz, I pulled all the problems from the quiz straight out of these homeworks. All right, the only thing I might have changed is graphing. Graphing is the only one that I didn't pull right off of the homeworks. Everything else, like these problems and stuff, I pulled straight off of the homeworks.
So they're exactly the same.
Exactly the same.
This will be a breeze.
All I did is I took problems that I saw and just put them on a piece of paper.
That's awesome.
The only difference is graphing, because graphing, I got to do something different, because otherwise you just studied. I think I made you graph like 4 things. All right, finish this up. Make sure you study tonight.